Here in this video, we are solving 3 questions that appeared in NEET 2022 in electric charges and fields, right. Let us see what is that first question is we are looking at. See, the first question is this. Two hollow conducting spheres of radius r1 greater than r2 are having equal charges. The potential would be. So, if we are having a hollow sphere, charge is kept obviously on the surface of the sphere having certain radius. Potential of the sphere inside or at the center or on the surface is fixed 1 by 4 pi epsilon naught q by r, where r is the radius of the sphere. See, if we are talking about intensity, electric intensity, that is 0 inside the sphere, but if you are talking about potential, that is same inside the sphere as well as on the sphere, that is inversely proportional to the radius of the sphere. There are two spheres such that r1 is greater than r2. So, as r1 is greater than r2, v1 is less than v2. So, it depends on the potential would be depends on the material of the property of the sphere. No. It is more on the bigger sphere? No. It is more on the smaller sphere? Yes, because it is inversely proportional to radius. It is equal on the spheres? No. So, the right answer is it is more on the smaller sphere. That is one simple question. Let us have a look at the next question. This is the next question. The angle between the electric lines of force and the equipotential surface is. First of all, what is an equipotential surface is? If you are having a charge q, around it there is a point where electric potential V is 1 by 4 pi epsilon naught q by r, which is a scalar quantity. And you can see all the other points are also at the same distance because this is the same radius. So, the potential is same. So, all these points could be called something like equipotential points. Around that you can draw another line that is also a equipotential line and so on, right. So, that is the equipotential lines, and we can also say electric field or electric intensity is perpendicular to this equipotential surface. So, electric lines of force and equipotential are having an angle of 90 degree, because electric field is radially outward from the charge, right. That is the second question. Let us have a look at the third question. This question, two point charges plus q and minus q are placed at a distance L as shown in the figure. The magnitude of electric intensity at a distance r, which is much greater than that of the L. Let us try to understand what he is saying. There is a minus q, it is called something like dipole having similar charges of magnitude but opposite sign, separated by a distance L, and now you have a point P. From the center to that point P there is a distance r, that r is given as much greater than that of the L. That means, the dipole size is much smaller than the point where you are trying to calculate electric intensity. Then electric intensity means at a point we shall imagine a unit positive charge. Now, you can clearly see that on this positive charge applies a repulsion, and this distance will become automatically r minus L. How much is that? Force on plus 1 due to plus q will be 1 by 4 pi epsilon naught, q1 is q, q2 is 1 by distance is r minus L whole square. Similarly, on this unit positive charge due to this minus q also, there is this is a positive charge, this is a negative charge. So, there is a force of attraction on that, force due to minus q, this is force due to plus q. Force on plus 1 due to negative charge is this distance becomes automatically from here to here, na? This is up to here is r, and this is actually you can say like 2L for the convenience, this is L and L. So, that the total distance is 2L. Generally dipoles are represented that way. 1 by 4 pi epsilon naught minus q into 1 by r plus L whole square. You can clearly see these two are in opposite direction, that means intensity is force on that due to plus q minus force on that due to minus q, because this is higher because this distance is less. So, I am not going for the derivation, it is the same is done in magnetism also. I have done it in my videos list of this chapter, electric charges and fields. You can see for a dipole electric field on the axial line, this line is called like axial line. It can be proved that this value is by simplifying the above two equations and by subtracting 1 by 4 pi epsilon naught q for L and R is the distance of separation. So, you can say capital R divided by R square minus L square whole square. This is the derivation. I am not deriving it, you can simply go ahead and derive it further, and it can be further proved that if R is much bigger than that of L, L square becomes much smaller. So, I can be ignoring it. So, it becomes resultant intensity becomes 1 by 4 pi epsilon naught q 4L and R by R square whole square, it becomes R power 4, 1 R will cancel, R cube. So, this is 1 by 4 pi epsilon naught q 4L by R cube. So, that is inversely proportional to R cube, that is the answer for the problem. You want just that relation, you do not need all these constants. So, it can be inversely proportional to R cube. Or else we can write this further as of course 1 by 4 pi epsilon naught q into 2L, where 2L is the distance between these two charges. He has given it like L, but I am doing it in a general format, q into 2L, which is also called electric moment by R cube, right. That is the standard derivation, right. Thank you for watching.